you'll need to be memorizing a variety of different polyatomic ions. And many of them are going to be related to the 8 polyatomic ions. And so you can see a lot of them here. In blue here we have, for example, carbon 8, nitrate, etc., all these blue ones. Now, you might learn in a psychology class that one of the best ways of memorizing things is by location, by geography. And so here I've set up all these 8 ions all on the periodic table. Like, you know that we have carbon here and we have nitrogen here, so I put carbonate here and nitrate here. Now, you might notice and maybe memorize a couple trends here. For example, all of the 8s except 2, they have 3 oxygens in them. So the only 2 that do not have 3 oxygens in them are phosphate and sulfate. So we have 3 oxygens here, and we have 4 oxygens here. And then you also need to be able to know the charges. Now, interestingly, we go from a charge of 2 minus to -1 as we go from left to right. And then in the third period, we go from 3 minus to 2 minus to -1. And so as we go to the right, we end up losing negative charge. So these are just kind of some general ideas that you might kind of recall in memorizing polyatomic ions. But there's a couple other ions that you should know as well. We've got cyanide here, ammonium, hydroxide. But there's also monoatomic ions that you should be able to name. Now, if you're dealing with some cation, generally a metal, such as, say, lithium, you just will call it something like lithium ion. It's very simple. If you're dealing with an anion monoatomic ion, though, the name is a little bit different. Nonmetals, like fluorine, if they are going to be negatively charged, we'll call them fluoride. Okay, so nonmetals, if they're negatively charged, we have them end in "ide." Now, if you are dealing with a transition metal, which are those D block elements, additionally, throwing in lead and tin, which also can have multiple charges, you need to identify what the possible charge is, because there are many possibilities. And so, for example, if you had Fe3+, then you would say iron 3 ion. All right, so those are some polyatomic ions. Now, we're very interested in these 8 forms because they allow us to memorize a variety of other polyatomic ions as well. For example, here we have chlorate in this box. You see, if you know the name and formula for chlorate, then you'll know so many other ions. You see, if you add 1 oxygen, instead of having 3 oxygens, you have 4. Then, instead of being called chlorate, you'll be called perchlorate. And if you remove an oxygen from chlorate, then instead of being chlorate, you'll be chlorite. And if you remove another oxygen again, then you'll be hypochlorite. Now, there are also acids. We need to be able to name acids. So if you know chlorate, if you add enough hydrogens to neutralize all the negative charge of a polyatomic ion in the 8th form generally, then you will be just calling it acid. So for example, you take chlorate. If you add a hydrogen, just 1 hydrogen here, then it will be chloric acid. So 8 is associated with ic. If you had perchlorate, then if you add a hydrogen to that, you'll get perchloric acid. Again, you're keeping the per there, and then the ic is associated with your 8. Now, if we take a look at chlorite and we add a proton to it, then we are going to be calling the acid chlorous acid. You see, us and ite are associated with each other. And then if we remove even another oxygen from chlorite to give hypochlorite, then we'll have hypochlorous acid. Now, some acids, or some ions, they might take more than 1 proton. So, for example, you have phosphate here. This has a 3 negative charge, and so it could take 3 protons before that negative charge is gone. And so if you are just going to add one proton, then you'll just call it hydrogen phosphate. Basically, you're just saying, hey, you have phosphate just like before, but now there's a hydrogen on there as well. Note here that if you're dealing with hydrogen phosphate, the charge has changed from phosphate. You had phosphate, this was 3 minus. When you grab one H plus, you'll be losing a positive charge, and so you'll have a 2 negative instead of a 3 negative. And then if you grab another hydrogen, then you could call it dihydrogen phosphate because there's 2 hydrogens. And here we only have 1 negative charge instead of 2 because, again, we have lost a negative charge by grabbing a positively charged proton. And finally, if you grab enough protons to neutralize all that negative charge, then you don't have to call it hydrogen something or other. You just call it the traditional acid name for your 8. So, or 8. So here we have phosphate, so we call it phosphoric acid. What if we had been dealing with phosphite? Well, then we would have phosphorus acid. What would be the formula of phosphorus acid? Well, it would be just like phosphoric acid, except having the us form, we're missing an oxygen, and so we would be H3PO3 instead of H3PO4. And finally, we also have binary acids. Binary means 2. So if you have, say, a hydrogen attached to very frequently halogens, like chlorine, and they're aqueous, that is, they're dissolved in water, then you might call it hydrochloric acid. What would you call HF? Aqueous. You would call it hydrofluoric acid. But sometimes, if these acids are not actually present with water, we don't use the hydro, because hydro, you know, means water. Actually, if we were just dealing with molecular hydrogen, or HCl, then we would call it hydrogen chloride, because it's not particularly acidic. If it's a molecule just floating around on its own, it doesn't have a lot to donate a proton to, for example. Okay, thanks for watching, guys.